Okay. Well, hello everybody. We're running this as a hybrid seminar today. First time we've done this, so you probably we'll probably have a few hiccups along the way. So please bear with us. It's a bit of a learning experience for us. So I'm talking to an audience here in the room. I think we have about 30 people here or so. But online, I'm not sure how many, but probably in between 100 and 200 people will be signing in online. So quite a big audience altogether. So, so today's speakers are closely involved in the development and software testing for the new Section 6 of building standards in Scotland. So we're going to hear about that, and there'll be some case studies to illuminate the talks. So I think it will be quite an interesting morning. At the end, we're going to have a kind of a panel session. So the speakers will be able to answer your questions. Obviously in the room, we can pick questions from the audience here, but also we'll be extracting some questions from the online audience. To the online audience, if you want to ask a question, please use the chat box feature of Teams, and we'll be able to pick up your questions from there. Okay, so and then at the end, when we have the panel session, you can ask questions then either of individual speakers or just generally to the panel. Okay, so without further ado, I'd like to introduce Daniel Foulds. He works for Building Standards in the Scottish Government, so that's, if you like, the fount of all knowledge about Scottish building standards. The updates to the energy standards came into force on the 1st of February, or will come into force, I should say. They were deferred from the 1st of December. Daniel is the Building Standards Section 6 Energy Policy and Technical Lead for the Scottish Government and heads up the ongoing review of the energy standards. So his session is going to provide an overview of the proposed changes alongside a discussion on future work. Daniel, hand over to you.
Yeah, thanks Jeremy. As Jeremy mentioned, I'm Daniel Foulds. I sit within the Scottish Government as the technical lead for Section 6 of the building standards. I would like to thank Jeremy and the rest of the CIBSE team for inviting me along today. It's been quite good to see so many people in person again. Saves being sat behind a computer screen, but it's also good to see, I can't remember the numbers now, but quite a big turnout for the CIBSE event today. It's worth pointing out this session of slightly modified slides were presented at a number of dissemination events throughout August and throughout the autumn and the summer. So if you've seen this before, apologise. Also apologise. It's quite a wordy presentation, but do bear with me. And then yeah, let's get started. Just a bit of an introduction, just to set the scene on how we got here today. So the consultation on energy standards. Whenever we change building regulations, it needs to go out to consultation. So there's a consultation which ran from July to November 2021. Quite a good turnout for that, 176 responses. And I've put a link on here. If the slides are shared, obviously you can tap onto these. If not, I'm sure I can share them, or I can send a link to where they are after the presentation. So the consultation and the consultation analysis was published online, and it's worth a read of the consultation analysis report. This sort of goes through the reasoning why the Scottish Government took the responses, analysed that, and then it gives the reasoning why it was then put into regulation itself. So it's a really good read. So following on from the consultation, the regulations were laid in Parliament on the 22nd of April this year, with their in-force date, which was amended to the 17th of June. You may have also seen the date was also amended in November. So the initial date was the 1st of December 2022 for the regulations to come into force. That has now been amended to the 1st of February. I'll go into a bit of detail later on about why that happened. So just moving through into some of the standards themselves. I'll sort of start through from 6.1 just through to 6.9, 6.8. I think I can't remember how far I go in this. But one of the major changes for the standards this time around is for the introduction of a new delivered energy target. So that goes alongside the existing emissions targets. The emissions target does still retained, but a new delivered energy target is introduced. And I've sort of put on the second line here around it being delivered energy, not primary energy. And again, I'll touch on a few examples of where that comes into practice a bit further on. But the scope itself for the regulations are unchanged. It still applies only to new buildings, on the construction of new buildings, and also to large non-domestic extensions. All fuels can still be used. And sort of building up towards the new build heat standards, which again you may have heard of, which were proposed in 2024, the existing emissions target no longer applies to any new building that does not use direct emissions heating system. So if you put a heat pump into a new build, your emissions target no longer needs to be met. So that's pretty much just shut off on the SAP calc or SBEB calc. And I put down there that is just leading into the new build heat standard for 2024. Just sticking with 6.1 and looking at the notional buildings. So the notional buildings themselves have been revised to deliver in new homes there and the new non-domestic buildings. So 32% improvement reduction for new homes and 20% for new non-domestic buildings. We actually consulted on two values for these. So for non-domestic, for new homes, this was an improved and advanced in the consultation. Was actually more favourable. More responses came back to say they would prefer the improved, the advanced reduction. I can't remember what the percentage now. I think it was more towards 50%. But it was felt within the Scottish Government that the market wasn't quite ready in 2022 to deliver that. So we went for the improved standards of 32%, and for new non-domestic dwellings, actually went between the improved and the advanced, which worked out to be about 20%. For new homes themselves, so we've moved from a 5 notional building situation to 3 notional buildings now, and that's applied on your main heating fuel choice. So basically heat pumps, a heat network, or any other fuel. So if you've got a biomass boiler being put in, you'll be compared against a natural gas boiler. That's where any other fuel comes in. So the notional building is the same across those three fuels, obviously except the heat generator specification. And also for heat pump building, there's no on-site generation included. So for heat network and any other fuels, for example, a gas boiler, the notional building assumes there's going to be some PV on there. But for heat pump buildings, it doesn't assume that there is no PV. And a similar approach is taken for new non-domestic buildings. And plus, there's been a slight modification for space and water heating, which are now assessed separately in a notional building based upon the specification of the actual building. And I put some minor points there, some amended guidance on shell and fit out and modular buildings. And there's quite an interesting one at the bottom there around orientation of your building. That's no longer going to be based on default values. It has to be based on your actual building. So yeah, sticking with 6.1 for a bit more. I touched a bit around on-site power generation in the previous slide. Appendix M1 now in SAP calculates the portions which are both exported and kept on site. I'll touch on a little bit the reasoning behind that in a minute. So there's now going to be more focus on measures at the building. This touches on the primary energy and the delivered energy point, where we felt in building standards that to capture things in building standards, the delivered energy metric, apart from instead of the primary energy metric, it's going to be more important. So it comes into play with, say, heat networks, where the efficiency of a heat network, the developer or the building owner can't really do much about that. So that's going to be captured by other regulation, which is going to come into force. Again, I'll touch on the reasoning why that's important in a minute. And it was also with the PV export element as well, where that does nothing for the building. So that's discounted from a building standards or a building regulation point of view going forward. SBEN does a similar point, but it doesn't take into account the export element itself. But what it does do is it takes a look at your equipment load, your plug-in load, and uses that to a similar effect. A really important point though is that last point now around EPCs, that the export component is still taken into account for EPC production. Just on that, there is going to be some consultation next year for EPCs going forward, so we'll just have to see what comes out of that. So I've touched on this first point, a couple of points throughout the presentation. So the consultation proposed that the performance of new buildings and the performance of heat networks are to be regulated separately. So the former point, the new building itself, the performance of the new buildings are going to be regulated through building standards and building regulations, and then the performance of the heat network itself are going to be regulated through pending heat network regulations or Heat Network Act. It's quite a simple method how that's achieved. So the efficiency of the network is still needed within your calculations, but all that's assumed is that your heat network efficiency is the same for your notional building and your actual building. So it just discounts, it just discounts each other. So it has no effect on your calculation. And heat networks, quite an important point here, are defined as zero direct emissions heat solutions at the point of use at the building. And so a heat network connected building no longer needs to meet an emissions target. It's just the new energy target. Just the last point on 6.1, just looking forward towards 2024. A lot of these are just repetitions from the previous slides, but it does provide a useful summary where the implementation of the 2024 standard, the new build heat standard, is going to remove the option of current at-building combustion solutions for new buildings. So from 2024, you're going to no longer, for example, be able to install a gas boiler. So that shuts off, and that means your emissions target no longer becomes relevant. So the introduction of the delivered energy target as an ongoing performance metric, removing the emissions target where direct emissions heating is not used, simplifying compliance for new buildings connected to a heat network. A couple of new points down here, requiring new buildings with direct emissions heating systems to be designed for easy retrofit with a future zero direct emissions heat solution. And then setting standards for wet heating systems based upon lower flow temperatures and which are compatible with heat pumps and heat connections. So just a small slide on building fabric. There has been an improvement in the backstop U values for the elements of the fabric themselves, and this is based on a 50%. There's an average of about 50% improvement of recent new construction. So it's a fairly decent improvement there. And that single set of values is going to now be applied across all new construction. So not just new builds, but extensions, alterations, conversions, and shell buildings. There are alternatives for modular buildings, which I'll put the annex there. And a point to note is that British standard, so building standards, hasn't updated their junctions or detail sets, so they're unchanged. Quite a big change for air tightness this time around has been that all new homes now need to be tested for their air tightness. It's not just a sample testing regime. There are some exceptions which are still retained for new non-domestic buildings, but these exceptions have been reduced. And then a note there for CIBSE TM 23, just like the rest of the UK, Scotland has moved to use that and adopt that as the base methodology for air tightness testing. But there is still an option for a low pressure pulse method, which is still recognised in Scotland. And I'll put that around. There are some options where an air tightness test can't be completed. So if that is the case, it's worth investigating around that. Now some building services points. I've sort of combined these into a number of slides. So the compliance guides themselves, so the domestic and non-domestic compliance guides, they're still being retained. There was quite an interest this year in the consultation and in feedback to actually combine these back into the technical handbook. So that's something we'll be looking at through to 2024. So the guidance on the need for space heating in domestic hot water and cooling systems to be sized appropriately sounds quite a simple point there. Wet heating systems to be designed to enable effective operation at a low temperature, and then fitting of self-regulating devices to emitters if they're not already present when replacing a heat generator. So it's not just replacing the boiler itself, it's replacing or adding on TRVs. There's a few changes, a few more here. Simplified guidance on pipework insulation. So now examples are cited and also reference to BS 5422 is made in the compliance guides. Just looking at some ventilation systems with MVHR systems, they should be fitted with heat recovery, obviously, and then some are bypass variable speed control where practical to do so. And there's been a brand new section in the compliance guides on on-site electricity generating systems. So where this, what this is trying to bring into play, it's mainly makes reference to manufacturer's guidance and making sure electricity systems are installed correctly. Some domestic only points here. So there's more reference to energy efficiency measures which should be introduced when gas boilers are being replaced. There's guidance on maximum daily heat loss for hot water cylinders in there, so that touches from I think between 400 and 1,000 litres. Can't remember off the top of my head, but then there is an equation if it goes above that in domestic properties where you need to meet that daily heat loss. And then there's a commissioning plan element where it needs to be confirmed at design stage with confirmation of that commission provided on the completion of the building. I'll touch on that a little bit more in a minute. There's some non-domestic elements here. So some key points at the front here. So air distribution systems, where additional advice on controls, expanded advice on air leakage from ductwork and clarity and test procedures. Some additional advice on lighting design and avoidance on over-illumination. And then a brand new section on controls, so building automation and control systems. But everything I've sort of said up until now on building services, those points there are the same across the rest of the UK. There are some minor elements just for Scotland, so there's a slightly different text on heat distribution systems to operate at lower temperatures. There's also around consequential improvements when you replace a gas boiler that has to cover both system and combi boilers. And then I mentioned about the BACs, the building automation and control system. That's triggered at I think it's a higher threshold actually. So it's 290 kilowatts for space heating or air conditioning. Delivered load, I think it's lower in England. So what we have done is we have split out the overheating element, which I think is sat within section 6 previously, but we moved into section 3, or at least made more reference to that in section 3. But what section 6 does, it now just refers to the overheating risk assessment, which has been moved for new homes and new non-domestic residential buildings. And that's just a simple, there's two methods of complying. There's a very simple method which I think it just takes into account all sections of a building which are not facing north. Plus I think you can still do a dynamic simulation model to prove that if that's not possible. So what the domestic handbook no longer makes reference to is the Appendix P of SAT, which is withdrawn, and that's actually no longer in SAT 10. And there's guidance on minimum efficiencies for ventilation and cooling systems, and these are all addressed in the building services compliance guides. So on commissioning, there's just a couple of points here, but where the new standards have come into force is where they explicitly include control systems as a building service. So that now needs to be commissioned. So there's also guidance introduced on the need to produce a commissioning plan at design stage and as part of the building warrant submission. And it also identifies the need to provide a commissioning report on completion of construction. And I've put there, I won't read that bit out, but it basically highlights the sort of the process that's been gone through from design stage through to actually as built, and how that commissioning plan may have changed. Just last couple of slides now. So this point here around written information, there's additional guidance on the quick start guide, and that's drawing more on overheating risk, especially making reference towards our standard guidance in standard 3. And then I touched on this point previously, where there's more onus on identifying where, for example, where you've installed a gas boiler, there has to be some information now on how that can be easily retrofitted into a zero emissions solution. So, for example, are the radiators need to be changed, or is it just the gas boiler or an alternative heat generator? And then, obviously, alongside all regulation changes, the tools which are associated with them have been updated as well. So now, from the 1st of February, SAP 10 and SBEM 6 are the new tools. The final specifications for these were issued to BRE back in April 2022. And partly because of the delays, the couple of amendments to the date of implementation of the regs moved from October to December and now into February. The development of these tools has been quite slow. I have to go through a few stages. So BRE need to update their Part L tools before Scotland can add on their elements to it. So, and then giving that to the third-party providers, the decision was made to delay to next year. Just pointing here that there is reference to the changes in both the NCM guide and SAP 10 specification. Just a few main points here with the changes. So the carbon factors have changed, mainly just to reflect the far lower factor for grid electricity. Previous compliance solutions such as offsetting of emissions from fossil fuel solutions through use of on-site generation are now far less effective. And again, just touching there on overheating, and Appendix P has now been removed. Just looking forward to onward work. So there was another consultation which ran last year, looking at a compliance manual for Section 6. And this forms part of a work which is looking towards a compliance plan approach to design and constructions. And where this is targeting is, there's always been the concern between a designed versus as-built performance, so that gap before that. So the compliance manual and compliance plan approach are trying to target that. This is a slightly different area with for my technical unit, but it all forms part of these. Just got some background noise here in the room. What this all forms part of is the compliance plan approach which we're developing going forward. And you may have heard of BESS, so Built Environment Smarter Transformation. They're doing a lot of this work for us. I'm working on behalf of the Scottish Government. Section 7 has also been updated. The original slides for this had a lot more on Section 7, which I'd cut out and simplified. But quite a major thing for that is, within Section 7 is EV charging points and infrastructure related to those, certainly for new buildings, and those subject to major renovation. There's been an update to Section 7 to include those proposals. And then there's continuing discussions again with BEST. So there's continuing work and discussions on standards beyond 2024, and BEST are also doing that work for us. So that's both working with the new build heat standard plus energy standards beyond the 2024 and moving forward as well from there. I've put my email address at the bottom here. I've put a few links. Please do fire any questions across to myself or through the building standards email address there. Yeah, thank you very much.
Thank you very much, Daniel. A fairly comprehensive run through of the new regulations. Next speaker is Harry Sharples, who is working for AECOM. Harry is a senior building physics engineer and is involved in testing the software for the new regulations. So he's going to present some case studies of assessments for non-domestic buildings. Over to you.
Morning, everyone. So yeah, as was just said, we're going to be running through some examples and case studies for the new standards, but it's kind of already been covered in the previous kind of presentation around some of the changes. We're just going to highlight for those that aren't familiar with the calculation methodology, kind of how it works. So as we'll kind of skim over some of this, but as touched on, it's broken down into 10 subsections, and the one we're going to focus on in terms of my presentation is going to be looking at the carbon dioxide emissions, so section 6.1 or standard 6.1. Predominantly in this presentation we'll be looking at new builds. There are implications on existing buildings and refurbishment works as well, but for the purposes of this and trying to keep it concise, we'll be looking at new builds. So the two key calculations that need to be done are a building emission rating and a target emission rating, and then also a building delivered energy rate and a target delivered energy rate. So these two are done through the use of either SBEM or dynamic simulation modelling for non-domestic buildings. And as discussed previously, the two supporting pieces of documentation are the NCM methodology for modelling guide and then building services compliance guide. And the NCM basically sets out all of the calculations that are applied to the notional building and also the calculations that are applied to your actual building. A couple of things to note that are worth noting is that when we talk about carbon emissions in this compliance respect, we're not talking about operational energy predictions, and there's a significant performance gap between operational energy and predicted energy from compliance. So if you are, by a client, being asked to look at operational energy, refer to guidance such as CIBSE TM54 or ASHRAE 90.1 or something similar. Another thing to note is that a lot of local planning policies use compliance modelling as a way of demonstrating carbon reduction. And for example, the Glasgow City Development Plan, and some of these may not have been updated to reflect the latest building regulation changes, and they may not be for some time. So there might be a requirement to do two sets of calculations, one under the old regs and one under the new regs, one for planning and one for building control compliance. So as mentioned, your actual building, which is based on your design, will produce a building emission rating and a building delivered energy rate, and a target emission rating and a target delivered energy rate, are produced by the notional building. It's worth noting also that if you're familiar with English regs, they are using a primary energy rate, and that is very different to the delivered energy rate. So the factors that are applied there between the two are different. And we'll go on to discuss that in a little bit more detail. So in terms of the actual building that's put into SBEM or into your dynamic simulation modelling, the inputs that you'll put in are your building room functions, your activity types. So for example, if it's an office, you would assign it to be an office activity type. You put in the architectural geometry and layouts, the fabric performance based on your design U values and G values, your HVAC efficiencies, your lighting controls and lighting design information, and domestic hot water systems and renewable technologies. Now, the NCM will then define, depending on what building function you're using within your building, what the usage patterns of that building are. So, for example, if it's a classroom, it will have set defined classroom activity profiles that it will assign for occupancy, for equipment gains, and for not for lighting gains, for equipment gains specifically. It will also set heating and cooling set points, so you have no control over those. The other key point to note is it will set your weather conditions based on location. In Scotland, this is always set to Glasgow. That's the only weather file you can use in Scotland, which means if you are doing stuff in the north of Scotland, your real-world performance is going to be very different to what's being modelled here because of the way the standards work. So just another reason why if you're doing operational energy predictions, you shouldn't be using compliance modelling. So Based on the information you input to your actual building, the notional building will then apply or pull over various items such as the room function, the level of servicing. So if you have fan coil units with heating and cooling, it will apply a similar system, but it will then apply a number of other inputs that are standardized based on a baseline. So for example, the amount of glazing, notional fabric performance values, the lighting efficiencies, and domestic hot water systems. So I think I've already kind of summarized most of that. So in terms of the changes to the standards and assessment method, the key things that have changed are a 16% reduction on the Section 6 2015 regs. And that's averaged over a variety of buildings, not just, so it might be different depending on if it's a school, an office, etc. There are changes to notional building fabric and the air permeability classifications. There's changes to the system efficiencies, the lighting efficiencies, and a key factor that's now put in is the definition of high and low usage domestic hot water systems. And that will depend on the activity type that you are assigning within your space. And that will then dictate what the notional building uses as its hot water delivery system. There's also key changes to the grid carbon factors and renewable offset carbon factors that the notional building uses and your actual building uses. And also the 2016 weather tape is being used as well. So I've gone back slide. So if we start with fabric performance, this table just highlights the difference between the new regs and the old regs in terms of what the notional building is assigned. You can see that the U values have all dropped by quite significant margins. Particularly things like exposed walls, we've dropped right down from 0.23 to 0.15. And there's also been simplification on whether you've got side lit or top lit activity spaces, which again, we won't go into too much detail for those that aren't energy modelers, but just that's the kind of summary of those changes. Now, the other key impact this has on your building is on what target U values you should be trying to achieve. So the target U values that we had in that previous slide are all based on inclusion of repeating thermal bridges, but notional building has a 10% degradation factor to those for the allowance for thermal bridges. Now, if you've not calculated thermal bridging psi values, you will now get a 25% degradation on your U values. So on top of the improvements to the notional building U values, you also have to be 25% better effectively than the notional. So you can see here, in order to meet the equivalent to the notional, which is in the brackets, so for example, for an exposed wall, it would be 0.165 U value with that 10% degradation, you would need to be achieving 0.132 for your average wall U value to meet the same fabric performance. So significantly improved fabric, which is going to be a challenge. And one other thing to note on this is that curtain walling, if you've got extensive curtain walling, the notional doesn't get prescribed the same curtain walling percentage, it ignores it. So if you've got 50% of your building is curtain walling, with a U value of say 1.5 or close to 2, depending on how many mullions you've got in the performance, your notional building is getting substantially less, 10% of the fabric performance of your building. So yeah, curtain walling is really a no-no, and it really does penalise your building in the new regs. So HVAC efficiencies. As mentioned previously, the HVAC efficiencies have simplified for heating systems. So instead of being assigned similar fuel types, it's now basically natural gas, electric heat pumps are the two options that are assigned. So you can see in the new regulations that if you are assigned direct electric in your actual building, the notional building will get a 93% delivery efficiency gas-fired boiler. If you are using an air source heat pump, it will be assigned an air source heat pump with a COP of 3, or an SCOP, I should say, of 3. Now, I touched on this earlier, but there's also the changes to domestic hot water system efficiencies. So, as you can see, again, it's been simplified, and there's now this definition of high and low usage scenarios. So, A high usage scenario is an activity type with greater than 200 litres per metre squared per year. Anything below that is considered a low usage scenario. And what this is trying to do is push you towards a decentralised system if you don't have sufficient demand to outweigh the distribution losses associated with a centralised system. So in a way it's good, but it's also can be a challenge depending on what the constraints of your building are. So if the notional building considers it a low usage scenario, it will assign 100% efficiency direct electric water heaters. If it's considered high usage, it will apply the centralised system, and depending on what heating output you're using, it will either apply natural gas boilers or electric heat pumps. Now, it's worth bearing in mind as well, if you have direct electric water heaters, often when they say semi-instantaneous water heaters, they may still have 10 or 15 litres of storage within them. And if they have that, and you've got a lot of those throughout your building, the storage losses associated with that can actually really build up, because the surface area to volume ratio means they have much lower storage or much lower efficiency storage per litre than a centralised system in some respects. So one to bear in mind there. For those that are interested, this is the calculation that's also applied for the distribution losses now to a centralised system in the notional building. But what's key here is that depending on the shape of your building, it's very likely that your distribution losses, when you actually calculate your secondary return loops and everything else, are going to be much higher than these. So you still will probably be penalised if you do end up with a centralised system because of that. So it's another one just to bear in mind. So lighting efficiencies. There's been changes to the way that the NCM applies illuminance levels, which is good because, for example, stores used to be 50 lux and no one designs a store to 50 lux. It's always 100 lux, so you're no longer getting that penalisation. But the notional building now has much more efficient lighting. So whereas before, using good LED lighting and well thought out lighting design could give you a real boost in terms of improvements over the notional building, you're no longer getting that. So as we'll see when we go to the case studies, that's a considerable, that's one of the easy wins kind of gone. And just a kind of quick touch on renewables. So if you're using heat pumps in your actual building, the notional building no longer assigns PV as a renewable on-site generation method. If you're using any other fuel, it will assign PV to the notional building. Now, these are the calculations that it uses, and the key thing here being that it bases it either on the lesser of your gross internal floor area or your foundation area. And the reason for that being, if you had a tall high-rise building, it's not penalising you because you've only got a certain amount of space on the roof that you're going to be able to put PV on. So also worth noting that if you've got heat pumps doing, for example, 50% of your load, and you've got direct electric doing the other 50% of your heating load, the PV is prorated based on this calculation, depending on the percentage served not by heat pumps. So the key other change, which is going to have a really big impact on your results, is going to be carbon factors. So you can see that the carbon factors for the grid supplied electricity are down substantially from previous and close to reality, and they also vary month to month, as previously discussed, which means that if your building is predominantly cooling led, you're going to have different carbon emissions to if it's heating led, because over the summer months the grid carbon factors are much lower. So what does this mean? So I've got 4 case studies. I just picked these because they're ones that I happened to test and I thought were quite interesting. So the first one is a commercial office, and a bit of summary. It's using fan coil units with air source heat pumps for heating and cooling, so 4-pipe simultaneous heat pump. It's mechanically ventilated, and it's also got quite a complex curtain walling facade. So here's just a couple of renders of the building with the, and I should also mention, sorry, these were all done in dynamic simulations, which allows for shading effects and stuff in much more complex ways than a simple SBAM calc. So most of the modelling I do is in dynamic simulation. So that's why you get these nice renders. So on the left, you can see the actual building comparing the 2015 actual building to the 2022 actual building. And you can see that, interestingly, most of the values are quite similar. There's changes to the lighting, which is predominantly down to the lighting illuminance changes. But what's substantially increased is our heating consumption of the primary. So you can see that we're now about 20% higher in terms of heating demand, and that's primarily due to those thermal bridging allowances basically being 25% worse. So you can see what kind of impact that has. What's more interesting is looking at the notional building. So on the right-hand side, you can see the 2015 notional building versus the 2022 notional building. You can see that your heating demand has dropped right down in the notional building, which is again due to the improvements to the fabric. But the lighting and the lighting has also dropped significantly, and again that's due to the fact it's using 95 lumens per circuit watt, and it's got the changes to the illuminates data. So this is just an energy consumption by by end use, broken just for the 2022 regs. So as you can see side by side that the notional is using much less heating demand than our actual building. Now this is primarily due to the fact that we have quite a complex facade that's all curtain walling, and you probably, this building by the way is not being assessed against 2022 regs, but if it was, there would not be this kind of curtain walling. But it also, in fact, it's got a lot of shading, so you're not getting those passive solar benefits in winter. So also interesting to note that the notional building does not have the PV because it's all the signs air source heat pump system. Yeah, so again, here on the left, you can just see on this example the difference in carbon emissions that the new regulations have. So you can see that the notional building between 2015 and 2022 has substantially dropped, and so is our actual building, and that's due to those changes in carbon factor. Now, interestingly, we're still somehow passing by 37%, which is surprising, and the only thing I can think of is that we've got a lot of PV on the roof, which is helping to offset that, some of those worsenings of the heating consumption. Right, case study 2. So this was a small primary healthcare facility. It had pretty good, or was pretty good, U values under 2015 regs. So it was triple glazed, 0.15, but we didn't have thermal bridging calculations for this. So again, we're getting that degradation on the 0.15s and getting much worse U values than the notional building relatively. It's using air source heat pumps for radiant panel heating, and it's using electric semi-instantaneous water heaters. So you are also getting a small amount of storage losses. The majority of the building, because of constraints around cost, is naturally ventilated, and again that means we're getting substantially increased heating demand. Now here's kind of again a breakdown of the actual building. You can see that our heating demand on the left is higher than it was under the old regs because of that degradation to the U values through thermal bridging, but everything else is relatively similar. Now, the notional building, again, we're seeing a similar pattern here, which is our lighting's dropped substantially and our heating has also dropped substantially. So what this actually means in terms of the regs is that we are no longer, this building, if this was assessed under the new regs, it would no longer be passing section 6. Now, what's interesting, well, on this particular one, I took the PV off because the roof was covered in PV and it was overshadowing everything. But when you ran it with PV included, it was passing by a country mile. But the point being that if you don't have renewables on your building and you've got some of these systems and worse fabric performance, you do end up in some cases being substantially worse. So case study 3, this is a high-rise student residency. It's got relatively poor fabric performance because it had quite a lot of curtain walling, which again is one of the reasons I use this as an example. And also this one has district heat network and there are changes to the way that the notional building is assigned district heat network carbon factors under the new regs. So this is just a couple of images. You can see that previously the reason we were able to pass was predominantly because we had what was considered a very good carbon factor on our actual building, whereas so even though we were having it under the 2015 regs, we had slightly higher heating demand. It was fine because we had that much reduced carbon factor. Now under the new regs, as you can see, the notional building on the right-hand side has dropped its heating demand substantially. And there's also been, and this one's particularly interesting because the domestic hot water consumption figures that the activity types are setting have changed from the previous activity types under 2015 regs. So you can see that the more hot water demand has substantially dropped due to the way the notional building is now assigning activity types and domestic hot water usage. So again, those benefits are suddenly completely turned on their head if this was assessed under 2022 regs. And yeah, again, you can see that this building, if this was assessed, would not be passing because it doesn't meet the TDR or the TER. Case study 4, this is an acute hospital. This one actually wasn't in Scotland, this was one I had in London, but it was the only acute hospital that I had that was kind of relatively recent. So this one had ground source heat pumps and air source heat pump combination, domestic hot water via CO2 heat pumps, and it had a lot of PV panels on the roof. So here's just an example of what the building looked like. And again, you can see that our actual building is relatively similar to the previous actual building. Now, in comparison, the notional building, when you compare the graph on the right, again, the heating's down, so we're seeing a trend here, which is the heating gets dropped massively in the notional, the lighting gets dropped massively in the notional, and there's no PV. So it's the same factors kind of are starting to become consistent over the case studies that we've been looking at. Now, as you can see here, under the old regs, we went from about 25% pass margin to less than 1% pass margin. So that's the sort of impact that the new regulations could have on buildings. And it's worth testing old buildings if you are a modeller to see exactly what those implications are and particularly what's driving those changes. So we're still in the testing phase from our end, just trying to figure out exactly what it is we need to do. But the key things are going to be the fabric changes, and on a lot of projects, doing side value calcs where you've got complex facades is not going to be feasible, but it might be something you need to start looking at if you have a lot of curtain walling in particular. So that's all I've got, but I don't know if we're doing questions now or at the end. Are we doing those at the end?
No, we're going to do it.
Cool, yeah, in that case, that's me. Thank you.
Thank you, Harry. So that was another view of the upcoming regulations. Our next talk's coming from a chartered architect, so maybe get a slightly different perspective on things. Richard Atkins, who I've known for a few years now. Richard has a track record in designing sustainable buildings. I think you've got some awards and accolades and trophies and all that. And he's going to talk about the technical changes to the methodology and implications of the new requirement to assess delivered energy for all new dwellings and the removal of assessing carbon emissions for new and net zero direct emission, or NZDE, dwellings. Just before I hand over, could I ask everybody to make sure they've filled out there's a couple of these sheets going around, and I've got some extra, so please make sure you fill your attendance, notify your attendance on one of these sheets before you leave, because we get paid depending on the number of, no, we don't get paid, but CIBSE does actually pay CIBSE Scotland, if you like, based on the attendance at seminars, so that will be a big help for us if you would do that. So without further ado, I'll hand you over to Richard.
Thank you very much.
Well,
good morning, everybody. Thank you for, first of all, inviting me along to speak today. I think a lot of what I'm probably about to say has been touched on to a certain extent, but hopefully the repetition of that will help it sink in. There's obviously quite a few changes to the SAP methodology being built into the regulations that come into force on the 1st of February in SAP 10.2. I represented the RAS on the Section 6 working group, which is always an interesting process to go through, because it is a process of grappling with what we're all trying to achieve, which is better performing buildings and improvements in not just fabric performance and systems performance, but reducing carbon emissions, whilst also trying to tackle issues like fuel poverty and heading towards the zero direct emissions ambitions for Scotland. And I think we're fortunate in Scotland that part of that solution has been the dramatic improvement in decarbonising the grid, which necessitates moving towards a sort of electrically fueled world. But that in itself presents a lot of challenges, partly in terms of producing enough electricity to supply that and in reinforcing the grid so it can deliver it, but also tackling the issues, as I mentioned before, of fuel poverty, where electricity as an energy source is considerably, at the moment, it's considerably more expensive than gas, typically as a fossil fuel. So in terms of talking through the changes in the SAP methodology, I thought probably the easiest way was to summarize some of that and then actually just quickly run through the different stages in the SAP methodology and highlight where the changes have occurred. Ooh. Right, that's not the button to press, is it? Yeah, I'll just scroll down. So the origins of SAP, obviously currently we use SAP 2012, but prior to that there were various versions, but it goes right back to BREEDEM, Building Research Establishment Domestic Energy Modelling. And that was developed during the 70s and through into the mid-80s, and it was based very much around research that the BRE were obviously commissioned to do at the time, to actually monitor a group of houses that they built down at Garston, which they monitored in terms of their energy use, and then they would set the task of how do you produce an algorithm that gives some level of prediction. And I quite often lecture in detail about SAP, and I have to stop myself every so often to remind people this is, in a sense, this isn't reality. This isn't modelling, as you've already seen earlier from Harry. This is a ready reckoner. All of the calculation methodologies, not just in the UK but through Europe, which have to comply with BSEN 13790, which is very sad that I know that number. They're all designed as a form of ready reckoner, and they do vary considerably. Obviously, SBEM differs from SAP, which differs from PHPP, which differs from the calculation methodologies used elsewhere in Europe. And those methodologies, whilst they follow the same basic principles, different countries, different regions will include different things within that calculation methodology. So we always have to remember that this is a compliance tool. They say in big letters at the top, this is not a design tool. And we need to be careful that we're not purely drawn by these tools into a certain recipe, a certain design for whatever building we're producing. We need to ensure we're designing fit for purpose buildings. But of course, you do need a compliance methodology to ensure that we are achieving, quite rightly, the targets that are being set. So the 2012 methodology includes a number of different calculations. Again, we regularly, in terms of the domestic side, we talk about a SAP calculation, but actually there's a number of different calculations within it. So there's an energy efficiency and environmental impact ratings, and those are the things that appear on the EPC. We currently have DER and TER, which is for compliance with local codes, and we have fabric energy efficiency, which also takes into account a cooling load. That's not regulated against in Scotland, but it's there within the methodology. And it also has a calculation of summertime overheating, which is appendix P, which was referred to before. The changes for coming into effect for SAP 10.2 in Scotland, well, first of all, the methodology is now 35 pages shorter, which I think is a good thing. It suggests there's a level of simplification. I think there's some provisions that will be applicable to Scotland, particularly in terms of delivered energy ratings, which aren't quite in that version of the methodology as yet. I might be wrong on this, but this is a I'm seeing a nod from Daniel, which is it's a good thing. And those are obviously coming along further down the track, not that far down the track. As has already been mentioned, Appendix P is being dropped in favour of standard, or indeed clause 3.14.8, which is in section 3. The carbon emission factors are revised both for the TER and the DER, target and dwelling emissions rating calculations. And the criteria to count the TER are amended to achieve, as already been talked about, to achieve around about a 32% reduction in CO2 emissions relative to the 2015 standards, which is the ones we're working to. So broadly in line with what at the moment would be a gold aspect 1 dwelling. SAT 10.2 includes target primary energy rating and the domestic primary energy rating. These aren't for use in Scotland. Again, Daniel pointed out that we had that conversation in the working group about should we be regulating against primary energy, or should we be regulating against delivered energy? And I think I've got my acronyms wrong on the last bullet point there. It's probably a TDER rather than a DTER. And that's just a sign of all of us, you write these things late afternoon without just double checking it, even though you've sat through all those working groups. But again, it's just an indication that we're going to have to get our head around new acronyms. And these have been introduced in order to reflect a move towards net zero direct emissions at the point of use. And Daniel's already outlined the fact that, come 2024, the option for fossil fuel heating will effectively be gone for new buildings. It doesn't then make sense to regulate on emissions if you've got a fuel source that means you've got no emissions or pretty negligible emissions. But of course, we can't just say job done, carry on as you were, because as I outlined before, the challenge we have is if you just converted everything to electric without further fabric improvements, without requirements for improved efficiencies in terms of coefficient of performance of air source heat pumps and all that sort of thing, the grid couldn't support that. And the most cost-effective way of saving energy is fabric first. We all know that. The building fabric should last much, much longer than any of the services that go into the building. So there is a whole host of changes listed within SAT 2012. I'm not going to go through these just now. What I've done is I'll walk us through the SAT methodology, and I've highlighted in those in red where those changes kick in. One of the slight frustrations that certainly I have, and I think a lot of people have over the last few months is, again, as discussed, the software has not yet been approved for the Scottish version, for 10.2. There are a number of software providers who have got approval for Part L. Not all of them have. They're all sort of playing catch up. In the absence of that, certainly frustration for me is not having the detailed outputs from a calculation software which I can compare directly one to the other. And I am one of those dull characters that will go through that line item in the spreadsheet and go, that number's different. Where's the algorithm? Where's the mathematics for that? So the latest version of SAT methodology and supporting documents can all be downloaded via the BRE, and it's worth revisiting the website because things are moving fairly rapidly. More and more information is coming online. Newer versions are coming through. So it's always worth going back and just double checking whether you got the most up-to-date documents. This is a slide I prepared quite a few years ago now to just demonstrate the complexity within the flowchart of a SAT calculation. And in fact, I use the word complexity there, and I shouldn't. I always like to say it is complicated, but it is not complex. It is not building simulation. It's a very self-referential algorithm, very similar in many ways to some of the algorithms within SBEM. And as I keep emphasizing, it is an engineered ready reckoner on the basis that the amount of information and the time that it would take to do a dynamic simulation of an entire building is, generally speaking, far greater commitment, certainly on the domestic side, than you could expect an applicant to go through. The amount of time that goes into creating a simulation program is pretty huge. So there is obviously a need to have as far as possible, a reasonably a quicker short-circuiting system. But as I say, you have to bear in mind its limitations. It is not a design tool. And I still, to this day, I mean, I do lots and lots of SAT calculations, as you can imagine. I will soon be doing more and more SAT calculations for the new version of SAP. As clients ask me, what difference does this make? What changes does this make? And I've learned over the years that rather than try and predict what a change in the calculation will result in, just do the calculation. Let's try it out. Because of this self-referential relationship within this complicated but not complex algorithm. And we have to remember it's an asset-based assessment. It's not an operational rating. It only takes account of the regulated load. So that's heating, lighting, ventilation fans, etc. It doesn't take account of the likes of the energy that this computer is using, for example. And again, as been highlighted before, historically there has been a significant gap between calculated performance and performance in use. Part of that is because performance in use tends to take into account regulated loads, unless you've got submetering, which is uncommon, certainly in the domestic sphere. It's doable, but it's uncommon. Plus, you've got on top of that the issues to do with quality of construction on site, which the industry is getting much better. And I think one of the big improvements on the domestic side that has driven that has been air tightness testing. So I'm incredibly pleased to see that air tightness testing will now be mandatory for every single dwelling, because it focuses the mind of the contractor on site that if they get it wrong and you end up with a leaky building, correcting that once you've got to the point where you can air tightness test it is extremely expensive. So it's really focused everybody's minds in ensuring that all the insulation actually is in, vapor barriers are in, they're properly taped, etc. In order to complete a SAT calculation, you need to, in terms of submitting a building warrant, you have to use approved software, and obviously the only way you can produce an EPC is to use approved software. I remember, I can go back long enough, when I actually did my first set of SAT calculations manually, which would have been probably about 2001, 2002. For those of us who've been at this for long enough, you may recall that when SAT calculations were introduced, or compliance calculations introduced, the first step in the regulatory journey was that they were an option as compared to hitting elemental or compensatory requirements within the regulations. And again, having sat on working groups for the Building Standards Division over the years, I've seen actually how that process works, which in itself is interesting, that in order for things to become regulated against, you have to highlight that there is an issue where regulation is appropriate. The first step tends to be guidance. The next step tends to be making something an option, but retaining the original option. And then the next step is you make that a requirement. And then the next step is you actually start to up the threshold of the point of compliance being reached. And again, it's to take people on a journey of, in a way, getting used to these processes. And again, we're seeing it here both with the current changes. Things are getting more complex, but they're getting more complex based on, firstly, an understanding of how the industry is working and the ability to the industry to deliver these things. But it's also based on a journey where things have already got fairly complex. It's not going from something that's very simple to something that is incredibly complex. Because we know the challenges that would create for the industry. As already been mentioned, within the SAT methodology, there's a combination of three things going on. Firstly, there are some changes to the algorithm that creates the TER and the DER, which take account of improvements in building systems and a better understanding of the algorithms themselves. There's also then changes in terms of upping the threshold what the TER, and then there's also the introduction of the what probably should be the TDER and the DDER, and this goes back to, as has been mentioned before, to looking again at energy rather than emissions. And in fact, the name of the title of section 6.1 has now been changed, or is being changed, from just carbon emissions or carbon dioxide emissions to energy demand and carbon dioxide emissions. And I'm guessing that when we get to 2024, the next set of the technical standards, reference to the emissions for new buildings will actually disappear because fossil fuel won't be an option. So we'll be purely looking at energy. There are 13 separate sections in SAP, and I will run through these pretty quickly, some much more quickly than others. I'm going to run through the ones where there are changes that will have an impact. I'm going to skip. I'm not going to skip over dwelling dimensions because actually, as somebody who one of my roles is providing the technical advice for the RIS certification of design scheme for Section 6, and part of that is setting SAP tests and then marking those. And dwelling dimensions is something that it is, I wouldn't say habitually, but is often incorrectly entered into SAP, partly because the way it's described in SAP is actually counterintuitive to the way that we work as design professionals. It was developed by a physicist. So actually people get the dwelling dimensions wrong quite frequently, which underlines the need to ensure that those who are undertaking SAP calculations or SBEM calculations have gone through a proper training process and have gone through some form of testing process and are doing it within a QA environment. Flues and chimneys, airflow rates have changed slightly, treatment of MVHR has changed slightly. Nothing has changed, particularly I think in the heat loss parameter calculation part of SAP. Non-repeat linear thermal bridging has already been touched on. One of the things that SAP does, and it's pretty much the same for SBEM, is where you don't know something, there is a default, and default is actually set kind of to penalize you. It's really designed to say, go away and do a bit more calculation, a bit more work on this. So, for example, a SAP default for the psi value of a sill is 0.08, whereas if you calculate them, typically it's 0.034. And that sort of order of improvement in performance you can see pretty readily on most details, and those details will be improving again, partly because we'll be increasing U values within existing construction, and that will also pull through some advantages on thermal bridging. One of the things that's been removed is in Appendix K, there were two lists. There was the default, and then what was called improved defaults. Those were never for use in Scotland. And again, those have been widely used. I see those appearing in SAP calculations that people submit quite frequently. They were for use in England and Wales if you were following the basic principles of the accredited construction details that were produced to accompany the English regulations. They were never for use in Scotland. And in Scotland, we have approved calculation details, which do have psi values. Those aren't going to be updated or changed or added to by the Building Standards Division. Those psi values should only be used if you are replicating those details precisely. The guidance is there. It's guidance to say, look, here are details that are probably better than the industry was doing 10 years ago. And if you follow these principles and calculate them, you'll get a better result. But they were never designed to say, I'm kind of getting there, so I'll just use those numbers. So it was a wide-scale abuse. So I'm certainly very pleased to see the improved defaults disappearing off Appendix K, because I think it has caused a bit of confusion, and it has led people, let's say, innocently wandering down that path when perhaps they shouldn't. Water heating is changing. So in SAP 2012, it's based on a assumed consumption based on the number of people, and the number of people in a dwelling is based on the floor area, and it's not necessarily an integer. It's a completely different calculation in SBEM. The revisions to SAP 10.2 will take into account where you have mixer showers running off a boiler, or you've got baths, or indeed you might have electric showers. And so it's a much more nuanced approach, which is incorporated in Appendix J. Also, flip side of that, or following on from that, efficiency of wastewater heat recovery will now vary with the shower flow rate. And the total energy requirements allow for distribution and storage losses offset by solar water heating. In terms of internal gains, the calculation for energy for lighting has been revised to reflect the enormous improvement in the performance of lighting, mainly down to LED, which is now feasible and probably the norm on domestic scale. And of course, one of the reasons why LED lighting is so much more efficient is that they don't give off as much heat. So you don't get the benefit of that heat as potential wild heat gain within a dwelling, albeit that's then caveated by the internal temperatures you've got and the utilization factor. Again, don't need to say too much about solar gains and the gain-loss ratios. These are just the next steps within SAP, and I don't think there will be an impact by the changes that we've already seen in the steps before, but I don't think there's major changes to this section. Again, if I was able to produce like-for-like reports, I could have been more forensic today and said, I found a little change in box 83, and let me tell you all about it. We'll get there. We will get there. Mean internal temperatures is the next section of SAP. And these assume certain heating periods. Those are changing, again, to reflect the research has been done to understand what pattern in dwellings, and that's changed over time, and it's changed with various different versions. There's a bit of a caveat on that, in that I think all of the heat pumps in the UK product database are designed to run 24/7. So there's a little wrinkle in SAP. This is particularly for those of us who do a lot of work for housing associations and RSLs, where part of the criteria will be meeting Silver Aspect 2, which is a maximum heat demand of either 30 kilowatts per square meter per year for a flat or 40 for a house. As soon as you move from a gas boiler to an air source heat pump, that delivers you a significant amount of efficiency in terms of the overall calculations. It reduces the emissions. It means that you probably don't need to put PVs on that dwelling. So instead of gas with PVs, you've now got an air source heat pump. But because it's running 24/7, it will actually result in a higher heat demand because there aren't cooling down periods. So that's always been quite a little bit of a barrier in terms of the uptake of air source heat pumps for RSLs up until now. RSLs, up until now, generally speaking, have been, in most instances, quite resistant to having air source heat pumps because gas, in terms of installation cost, is more cost effective in terms of gas boiler, and it's a known quantity. They understand how that's working. Some housing associations have had issues in the past with tenants pushing back from having air source heat pumps because they haven't felt that they're as easily controllable. They've not necessarily seen the performance that they might deliver. I think in recent years, air source heat pumps have now become far more viable option, which again is reflected in how the regulations are developing. I've now installed an air source heat pump in my cottage, which is reasonably well insulated, and so far it's coped with it being -7, which I'm very pleased about. Not sure whether that will reflect in the bills when I get them next month, but we'll see. It's the direction of travel we're going in. Hopefully I'm reasonably on time. I've not got vast numbers of slides left. The next part of SAP is the space heating requirement. Again, the results will have changed, but there's no specific changes in the algorithm that I've identified. HC8F is the space cooling and the fabric efficiency, which we don't regulate against in Scotland. Notwithstanding the fact that it's been -7 recently, it's not impossible that in years to come we will be regulating against space cooling requirements, partly because we're making fabric so much more airtight and so much better insulated that there is potentially a growing problem with overheating. And again, this comes back to not just following a SAP or an SBEM calculation, but understanding your building. If you're going to insulate a building that well, you need to think about the orientation, you need to think about the solar shading, you need to think about the ways that you can passively ventilate that building, which are all perfectly doable. I've done them many times. But we need to start thinking about that, and those who are architects, building designers in the audience, we need to start thinking about that right at the beginning of the process of design, and talking to your CIBSE engineer, for example, to say, look, we need to do some reality checking here to make sure we're not veering off in the wrong direction. Sadly, I see too often architects having sold the glass box concept to the client, then turn up with the engineer and go, well, how do we make this work? And it's, it is head in the hands time. They've started from the wrong place, unfortunately. And you heard that earlier with in relation to curtain walling, which I thought was very interesting. It's the same issue. So this takes us on to section 9, the energy requirement within SAP. And there's a few changes in there. The treatment of heat losses has already been touched on in terms of communal systems. There are additional options for flow temperatures and heating systems. A lot of little individual details, if you like. One of the things which I'm very pleased to see, not least because I did an exercise on this for a client probably 6 or 7 years ago, is the option of including thermal space heating. So this is where you have thermal solar panels on the roof, and you would tend to have a large attenuation tank. You can actually get enough energy out of that to not just do your hot water, but actually provide an element of space heating. So I'm pleased to see that's been included, and there's provision to include heat interface units and additional controls, and a whole bunch of other I'm not going to say minor details, because some of them could have quite significant impacts, but there's a whole bunch of details that have been incorporated into SAP 10.2. Importantly, and this was touched on before, is the changes to the self-use factor for electricity. So under the current regulations, it was not uncommon if you're building blocks of flats to put in a reasonably large PV array to reduce emissions, but then to run that through a landlord supply. That achieved what the regulations were trying to achieve, which is reducing CO2 emissions, but it didn't actually benefit the tenants or the owners or the occupiers of those units. They didn't get the benefit of that electricity. So to get more of a real life benefit of that, has to go through their meter, but actually they've also then got to have some use for that electricity or the ability to store it. So the current solution, if you like, which might be a gas boiler with quite a few PVs, will be harder to demonstrate compliance unless you have something like an electrical storage battery or a PV diverter, which will take that energy and put it into your hot water system, or you've got some form of reasonably continuous electrical demand. So you might have NVHR, you might have an air source heat pump. So basically you can soak up all that lovely low emissions electricity that's coming off your PVs. Within the SAP methodology, this is where the actual SAP calculation, which produces the EPC, your DER, TER, your PT, PDR, and all the other ones start to diverge. As a user, you don't have to worry about any of this. All these calculations are being done simultaneously. But the current report, certainly for the software I use, runs to about 28 pages for each SAP calculation. I'm guessing it's now going to run to, I don't know, 36, 38 pages, because you're going to have these additional calculations. And they are very useful because you can dig into the actual numbers and say, all right, how did you get from there to there? What is a bit frustrating, and again, I see a lot of SAP calculations that come from different versions of the software. They don't have a comparative layout. So particularly when I'm trying to mark somebody's SAP calculation and I'm trying to figure out why their calculation is different from mine, in a way I'm not interested in the end result. I'm interested in the workings out, because you can have self-correcting errors within a calculation, as I'm sure you can in an SBEM calculation. It's actually really quite difficult to follow the two streams of calculations. It's a bit of a bugbear, but there we go. The last 4 sections, again, I don't think the algorithms have changed massively, other than, as you'll see on the next slide, the emissions factors, cost factors, and the primary energy factors. But the process, the stages within the calculation remain pretty much the same. Like I say, fuel costs, emission factors, primary energy factors have all been revised, and as been pointed out, will now take account of monthly fluctuations. So, conclusions. Had the changes to the methodology happened out with changes to the regulations to improve performance, I think the result would be that because the DER and the TER calculation should take into account the same changes, a building that was compliant before would still be compliant. In a way, we've got an extra layer of complexity because we're also changing the targets. So quite what the answers will be, in a way, we won't know until we've run enough calculations. And a bit as was said before, particularly for on the SAP side, where you don't have the software available yet, you just need to sit down and run 50, 100 calculations of different types just to get a sense of where the changes are. But of course, with the addition of the DDER and the TDER, as it probably should be, it doesn't necessarily mean that a dwelling that passes in terms of emissions will pass in terms of energy. Of a little bit of modelling that I've done so far using the BRE's ISAP software, which is out there and which is available, the conclusion is if you had a dwelling that was meeting gold standard 1, gold aspect 1, it will probably still be compliant. The calculation now, I guess I was going to say favour, but actually redresses a bit of a balance where it's becoming slightly easier for a smaller dwelling to comply relative to a larger dwelling. Traditionally, historically, when you look at SAP calculations, the bigger the dwelling gets, actually the easier it is usually to pass a SAP calculation. And the reason for that is you actually got more fabric to improve. So if you've got a target of whatever it is, 0.15 for the walls, and you make it 0.13, self-evidently, if you've got a lot of walls, you're going to get a proportionally bigger benefit of that. If you've got a little flat, which doesn't actually have much building fabric, you've got not much to keep improving on. So I think that's a good thing, because obviously the bigger house, the bigger dwelling is going to be using a lot more energy anyway, and producing therefore more emissions, depending on the fuel cost. However, the changes to target setting process, as I say, is a just compliance solution. So self-evidently might not be compliant in the new version, and the road compliance may not be straightforward. And like I say, I think we're going to have to do a lot of testing on that to work out exactly where that goes. Now, hopefully I'm going to be forgiven for doing a little bit of a plug for the RIS certification of design energy schemes, which are run in tandem with CIBSE. We're very grateful for that relationship. Hopefully everybody's aware of certification of design, if only from Section 1, the SER scheme. The schemes exist for Section 6 in Scotland and have done for a long while. A certificate of design certifies the design described in the application is compliant, and it's only valid under the active issue by an approved certifier of design. Effectively, the certifier of design who should be working within the design team may be the actual designer. I'm a certifier of design. I work with other architects, and I also certify my own designs. As part of the team, on one hand, you take on the role of the local authority verifier, so you do the checks that they would do. But as part of the team, you're there not just to assess compliance, but help optimize the building. It's back to that, having someone in the team who says, I know how the calculations work, and I know how to work to get compliance, but don't forget, we're actually trying to aim for fit-for-purpose buildings. We mustn't lose sight of what it is we're actually trying to design. The building regulations, and hopefully Daniel will forgive me here, the building regulations is not about creating necessarily fit-for-purpose buildings or even necessarily good buildings. It's there to create compliant buildings, buildings which meet the criteria of the regulations, not just on energy, but in terms of access and safety and all those other things. You are entirely allowed to do daft things when you design a building under the regulations. If you want to have all the curtain walling you possibly have and very poor U values in the walls, as long as you don't mind putting a shed load of PVs on to make that happen, you're allowed to do that, because that meets the emissions targets, meets the energy target. Our roles of designers is to actually say to the client, you're probably better off spending your money in a different way because you'll get a better building, which will still be compliant. And a certified design is there to help optimize that solution. As I said before, it brings together the RIS, CIBSE, CIAT, and I provide the technical support through Home Energy and Data Services, and we're supported by the ARB and the RIBA. So I would urge any of you to have a look at the website. If you're not certified as a design, please apply. We're looking for more people. The Scottish Government is committed to making certification of design the norm, and there are benefits for all of us in providing that because it's an additional service that we can charge for. It also gives a discount on building warrant application fee. And that's me. Hopefully I've kept reasonably to time.
Okay. So we have one more speaker, and we'll be hearing from another architect, from Mast Architects, Michael Jarvis, who's going to talk about how standard changes will help shape buildings of the future. So he's going to run through some of the proposed changes to Section 2, fire for the building standard. Sorry? Just Section 6, I beg your pardon. Just Section 6 then, and provide an overview of what future changes might be introduced in 2024 as we move towards zero emissions heating in new buildings. Over to you, Michael.
It should. Yeah. Apologies all, I seem to have closed everything down and cut you all off. So again, my name is Michael Jarvis, Mast Architects. I am an architect who obviously can't work technology, and I'm going to run through, as an architect, my thoughts along with Morgan, who was going to be here, thoughts on Section 6 upgrades and what's in the future. So just to go through this all, as you all know, repeating everything what everyone said, the regs are going to come out 1st of December. They're now coming out on the 1st of February. We then have another literally 2 years until the new regs will come out, which will be a much larger, hopefully, way forward and what the energy standards are going to be. And then in April 2024, we have the zero heating systems where gas won't be able to be used for any new buildings. Again, I'm sort of repeating what everyone said, but I've just got nicer diagrams to show it with you all. So basically, we've got 32% reduction, which is basically in the regs, as us architects looking at as it's going to gold 1. So it went from bronze to silver to gold. We're now looking at a new, rather than carbon, a new energy calculation, which is a much better way of modelling it. The amended notional building types, again, I think was mentioned earlier on, was we'll be using sort of gas, air source heat pumps, and sort of communal heating systems. I say gas is like any other fuel, but it will go forward to sort of basically be, rather than lots of different fuels, it's like any other fuel. I'm looking at my learner colleague there to make sure I'm not saying anything wrong. And it's SAP 10.2 we're going to move to. There was a little bit talking earlier on about notional backstop values. So this is what was in 2021 and now is in 2022. So basically external walls were 0.22, they're now going to be 0.7. And we've given there what you can see all the notions for 2021 and the 2022 and what we think they will have to be. Now, for housing and social housing, which I predominantly work in, our current model is 140 mil kit, a carrier board or some sheathing board, and then 25 mil of insulation. We believe that when the SAP 10.2 comes out, we will have to probably put that down to up to 50 mil of insulation with a service zone. The other thing that was before was there was lots of conversions, extensions, alterations, and conservatives. There was all different types of backstop values. They're now all the same. So there's that, you don't have to go and link to all the conservatives 0.15 or 0.6, they're now all the same. So your backstop values in here, 0.17, 0.12, 0.15 and 1.4 are all the same for all types. Again, psi values, I'm sure a lot of you work in non-domestic have been doing this for a long time. Richard and I started looking at psi values 14 years ago, and we have been, as a practice, we've been leading on that for 14 years, and then it's now becoming the way forward. As Richard everyone said earlier on, if you don't calculate your psi value, especially for domestic properties, then you're going to find it very difficult to pass pass a sort of section 6, or even get a SAP calc that works. These all have to be calculated, and again, by being the non-linear thermal bridging that it is, the more you calculate, the better it's going to be. So for Richard and I, looking at this over the last 10 years, we've been trying to get down to, it was 0.7 was the and then down to 0.2 and 0.3. I think it is, again, I'm probably talking to the converted, but it is for architects especially. Very few of us know what these are. Very few of us care what they are, if I'm being very truthful. But it is going to be the next biggest thing, architects having to understand what a psi value is and why it works. And also it helps very much to get aspect 2, which comes into a lot of our funding models from Scottish Government. What was mentioned earlier on, so there's also air tightness tests. The air tightness tests are going to have to get done in every building going forward, which means the contractor just can't choose the 1 in 20 that they built better. They're going to have to get every single one done and then decide if they're going to put a hole in that one or go and gunk it up more, because that's the way it's going to be and the way it is on site, unfortunately. But it does mean that when you're dealing with contractors and understanding this, you need to make them aware that this is something new. So if they're handing over 20 properties and they want them all handed over next week, then you're going to have to tell them you need to get 20 air tightness tests done. Because if you don't, then you're not getting them handed over. You can't just say, I'm going to get one done. So it's much more practical. Truthfully, I don't know if that's the same in the non-domestic regs, but you're building one big school, you're not building 15 or 20 at a time, unless you're very lucky. So again, with housing, if you're building volume housing, these are going to have to get done. And it would just really show you there where sort of typical builders build them wrong by just drilling 100 mil hole through a wall from the inside and then thinking that they can just stick the flue through it. On ventilation types, they have been more prescriptive now. So natural ventilation is over 5, continuous mechanical extract is over 3, and below that would be continuous supply and extract ventilation. I know it was mentioned earlier on that it's recommended that it's heat recovery, but the regulations as I see it don't prescribe you have to use heat recovery. It would be a bit silly not to have mechanical extract ventilation continually and extract and input in ventilation and not have heat recovery, but I don't, is that right? The regs don't prescribe it to have to be that way? It doesn't have. Overheating of the buildings, which again 10 years ago people would laugh at you in the street if they talked about your building in Scotland was going to overheat and all the rest, but it is now a calculation you have to look at. There's assessment of risk. There's a simple methodology which us as architects will use, and then yourself as all being more learned colleagues will probably use a dynamic thermal analysis because it probably works a lot better. It's not something we've really done a lot of work into at the moment. So PV, notional dwellings and SAP assessment will now include PV provision. So as was talked earlier on, the PV was always shown as a factor of going to the grid. Well, PV will now be shown as all going into the dwelling. If you put too much PV in your property, and that can show in SAP that it's an overuse, then it won't be part of the calculation unless you can show that you have somewhere to store it. Now, for us as a practice and what we're promoting to a lot of our clients is that this is not a battery, because not only a battery is not good for the environment, they're also very expensive and they also don't last as long as they should. And I don't believe at the moment, if you really look at it, what the payback is from the PV you have in a house to what the battery costs, you're not really ever getting a payback in that. People will argue that, but I've looked at it even from my own house. And what we're pushing forward now is, especially at the moment, is for clients to put in system boiler systems where you can connect the PV in and have that as a diverter or converter into the hot water cylinder to give you more hot water directly. And that is also being used a lot up in Shetland and other places at the moment where there's a lot of electrical or heat dumping going on, where thousands of social housing properties or other properties are just having energy in Scotland, which everyone knows Scotland's got the 25% of the wind from the whole of Europe, but it doesn't always happen when the football's on and when EastEnders is on or when you want to make your dinner. It quite often happens in the middle of the night where everyone's asleep and nobody really wants to use the energy. So there's a lot of issue at the moment where all that energy just gets dumped because it's got nowhere to go. So again, there's a lot of looking forward in the future to how we can utilise that, and let's talk about using electric cars and dumping overnight. There's also the utilisation factor, which I talked about, and direct supply. So for flats, when you weren't using sort of standard housing for flats, 3-storey and above, or even cottage flats, you were able to take this PV and put it into the communal spaces and heat your lighting and do whatever you want. Now, in SAP, it has to be directly to that property. You can't offset it and use it. It has to be, the PV has to be used directly for a property, which is a big change. And it's a good change as well, because I think it was always a bit of a get out clause where you could put lots of PV in a roof and then say that all these dwellings are all getting lots of electricity, and then just basically put one converter in and get all the lighting for your close and everyone else signed off. This is one that Richard and I worked at a lot, is especially for architects, is the way your buildings are orientated. People don't really get it. The fact is that unless your roof faces south, then you get 100%. As you orientate that building round further to the east-west, or if you go out to Tweka, somewhere on the north side, I don't understand how that happened, but if you go out there are houses that have the PV panels on the north face on the north face. But as you move round to go east-west, the factor of how much that produces up as much as 50%. So if all the PV on the property is facing east-west, then you're only producing half of the amount of that. You get 5 kilowatt system, you're only producing 2.5 kilowatts because you're only getting half the energy in it a day. So again, it's a bit looking at stupid design and rather than more practical design. Heating systems, again, we're all pushing forward to using low energy systems. So that is using heat pumps. As we talked before, you now have to design for those being in the future. So if you have a hot water cylinder and you have larger radiators and you design that in now, it means if it's a heat pump or heat pump become better, then you can easily add that on, rather than if you've got a combi boiler and small radiators now, then what would happen is when you go to put a low energy system in, you have to rip that all out and put new radiators in. People will not understand it. Again, I think when you go and you put in as a wet system in with radiators rather than underfloor heating for air source heat pumps, I think people won't understand as much that the radiators won't get as hot. They're just bigger and they're just a bit cooler. That's just my thoughts. Commissioning, this is another thing that's going to be a bugbear for architects, I can imagine, and obviously the commissioning plan now has to be agreed at the building warrant stage. So you have to agree, this is your commissioning report, your heating, hot water, ventilation, cooling, control systems, anything has to be agreed. It becomes part of your warrant. And again, when you're going to do handover of your building and you want it to be habitable, then you have to basically have the certificate. You have to have this all signed off. It's not just, well, maybe we'll do it. There's a lot more information that has to get done, including, as you say, airtightness testing of every single property. Now comes to the fancy wee diagram of what I see for housing as being one of the way forwards. There'll still be gas boilers with oversized radiators. You'll have to have increased your PVs. It does say battery storage, but it's any kind of storage. We think there will be an increase to the PIR insulation to the outside walls, improved loft insulation, double glazing, and we think we're probably able to keep the floor spec as very much standard. We're probably going to go for an air infiltration rate between 3 and 5, which means using CMEDs and DMEDs. And that is what we see as being the most practical and economic way, as in working in social housing and having been government funded. We'd love to do everything in passive house if we could, so we'd love to do everything, putting PVs in the roof and do everything really fancy. But at the end of the day, we've got to make sure that the money that we use from the government and the private finance from the housing associations or the councils is used practically. What we have done here is, again, it's a little bit to do with government funding, but we have looked at how much we think on a standard property the new regs are going to cost. These were clarified with a QS just 2 days ago. So we think it's going to be about £7,000 a property. If you are doing social housing, you'll get some additional government grants for that, for going for all your aspects, silver aspects 1 to 8, so £2,500. But you are talking £7,000 odd that it will add to a building. 2024 comes along. We don't know what's going to happen, so we're just making this up a little bit. Oh, I'll put this in full screen. Yeah, that'll be better. Yeah. So we think it will all be air source heat pumps. You'll need PVs, and you'll probably need a smaller battery storage, because if you've got PVs and you've got an air source heat pump, then obviously you're going to be using a lot more electricity. So you don't need this massive big battery, because you're going to start using it. I also think as well, which is not talked about, is that because we're not doing gas heating, then people aren't probably going to put gas in for gas cooking. So again, you're probably going to end up with more electrical induction hobs, which again will work better with the PVs and the roof. Again, people having to learn to do a washing in the morning and then do dishwasher in the afternoon and do things like that, so you're using the electricity in the right way. We think that it will still be 25 mil of insulation like it is for the moment for the Green Regs, improved loft insulation, probably triple glazing, and triple glazing, and also, well, I think a lot looking at the different values of the different glass you've got, because it's not just 3 sheets of glass, it's 3 sheets of glass that have different E factors or different reflective values on them, whether on the north side or south side of a building, and how much that keeps the heat in and reflects the heat. It makes a massive difference. We think that we're going down to an air filtration of 1 to 2, which will mean you'll have to have a MVHR unit. Again, it doesn't have to have heat recovery, but you'd be stupid not to. So that's our thoughts on the new building. It's not exactly the greatest design house, but it's what a section looks like. And again, this is what we presume the costs are going to be. So we're thinking come 2024, it's probably going to add about £27,000 onto the building of a house. But for social housing, that's quite a lot. For volume house builders, it seems a lot, but when they're selling a house for £400,000 and £500,000, it's not really that much money. But whether the volume house builders will find workarounds to get what they can, as they usually do, to make things not as they are. The also other cost, I think that whether you're a tenant, whether you're buying your house on your own or whatever, is the maintenance costs, because you're putting a lot more technology. People are going from a standard house where they have a combi boiler which lasts for 15 years, needs a little bit of service. They've got standard extract vents which you can buy in B&Q for 50 quid, and you can refit them when they go. You're now talking about a lot more sort of expensive. I live in a house which is all triple glazed, it's all super insulated, it's underfloor heating, and I've got a heat recovery unit, which is a nightmare. I know I'm going to have to spend, after 4 years, I have to spend £350 having it serviced, and I'm thinking to myself, how much have I really saved from that heat recovery unit? And I've got to spend £350 plus change the filters twice a year. It all sounds great, but whether or not in reality these pieces of machinery you get, do well. Again, underfloor heating sounds great, but then if you put a carpet on top of it or a rug on top of it, then it doesn't work as well. If you wanted to live in Spain and you just want tiled floors everywhere, it's brilliant. It heats up your feet really quickly. But you put a laminate floor, you put a wooden floor, you put carpets, rugs, anything on top of that, then it doesn't really heat the building up that well. How long did I talk for there? Enough? There you go. I can talk all day if you want.
Okay, thanks, Michael, for that. So that concludes the formal talks. We're now going to arrange a panel session. That will take us 5 to 10 minutes to set up. So please go off and have a cup of coffee or something, and come back shortly, and we'll continue. Okay, so we're going to start the panel session. So do we want to start with a question from the online? So that we're thinking of them. I hope you can hear me. So if I don't hear anything from Ella, I'll assume that's the case. So we've got the four speakers here. You can ask questions directly to any one of the speakers, or you can ask a general question for discussion. Okay, so we're going to start off with a question from the online audience, who are still with us, I hope. Jamie?
So we've got one question which is probably for Daniel, which is what's the cut-off for carrying out projects under the previous, the 2015 regs? Is it just planning or are there other requirements?
What's the cut-off
for carrying out projects that would have to comply with the previous regulations rather than the new?
It's still just down to the your building warrant, so it's just apply for building warrant. So if you apply for anything applied after that, you'd have to sort of apply with that with the new regs.
So then another question from online is about weather files. Why do we use 2016 weather files for general compliance and then 2020 for overheating risk?
Well, for overheating risk, if we're talking about dynamic simulation modelling, the overheating risk would be using the design summer years, which look at overheating and specifically take it from the period, so if it's 2020, it would be looking at predicting 15 years in the future and 15 years in the past, applying a high risk overheating scenario. So you use elevated summer temperatures, whereas the test reference year, which is what's used for the energy calculations, is an average of that 30-year period to give you a typical usage scenario. So if you were doing operational energy predictions, you might test it under different weather tape scenarios, but for an average energy consumption, you would use a TRY summer file.
Okay, any other comments on that?
Yeah, only in the sense that, you have to, the regulations have to remain consistent during their lifetime. So if you were using different weather data from one year to the next, then you would potentially have a different level of compliance. So clearly, from anywhere between 2015 and 2022, the same design should have been consistently compliant.
Okay. Shall we take a question from the audience? Anyone? Yes?
I may have missed this at the start. I turned up late, but I didn't get a definition of delivered energy rate and what that means. Is it energy consumption or is it energy demand?
Okay, so I can take that. It's slightly different. So just going back to a bit of story. So the two elements, you've got the delivered energy and primary energy. So primary energy takes into account the efficiencies of the systems outward the building. So heat network efficiencies of the grid. And that's something building standards isn't going to be looking at going forward, certainly for the new reg. So from 2023, it's going to be anything that the building can do itself to affect the energy system, which would be the delivered energy. So delivered energy and primary energy in terms of consumption and demand are, I suppose, the same one. It's just the delivered energy aspect will be what is actually used at the building. It's like with the PV element now, where the export of PV is no longer counted in your building regulations compliance calculation. It used to be, but now anything you export is discounted from the calculation. So that export element would be almost like your primary energy element.
Primary energy, but as in the demand of the building, really? You're tiring that, or I'm just trying to understand this. So what I understand is that the primary energy takes into account the efficiency losses within the power plants, etc. The delivered energy does not. Is that correct? Yeah, it's basically just what's coming in as a demand into the building, but not demand, but consumption. Yeah.
It would be what's consumed and then taken from say PV.
Right. Cool.
Yeah. So if the generating station is producing 1.5 kilowatts, by the time it gets to you, you've only got 1 kilowatt. That's your demand energy. It's the regulation is looking at that 1 kilowatt you're getting, not the 1.5 that's come out of the generating station.
Right.
Okay, another question from the audience?
You spoke about the changes.
Could you speak up because it's just one microphone?
Mike Smith from McDonald Water Storage. You mentioned a change in the calculated hot water use per day based on 38 plus 25 per person. What storage temperature is that based on?
Well, that's a good question. That's a very good question, and I'm waffling because I don't know the answer. I'm not sure. I'm sure somewhere within the SAP algorithm it will take account of heat losses out of the hot water cylinder, and it will take account of the temperature that you're taking the hot water up to. But in terms of the overall volume, that particular part is just calculating the volume of hot water. Okay, so yeah, it's one of those things that I might take that question away and delve into a SAT calculation somewhere in those 28 pages to find out what that assumption is. There will be an assumption in there somewhere, and I don't think it's been amended to take account of the fact that we might commonly be heating hot water cylinders to a lower temperature now, in part because they're better insulated for a start. Yeah.
Okay. Any other comments on that? Okay, let's take another online question.
So one person online is saying that IES Virtual Environment has brought in the calcs for Section 6 for 2022. Is there other modelling software that is already available and able to do the?
So the IS have this exam approved we've approved the SPEC account. At the moment there aren't any others have been approved. They are forthcoming through to February 2023.
And another question is it the case that if you meet the delivered energy target, that you can exceed the backstop U values? The question was in relation to domestic, and then the person asking that question is also saying, does that also apply to non-domestic?
I'll happy to jump in on that. Yeah, the whole point of having a target setting mechanism is you've got freedom to do different things. So you might want to have building more glass and less walls. So you improve the walls, or you put PVs, or you've got a whole bunch of different things. So the whole point of setting a target is to give the designer more options. And that's partly why, as I said before, it doesn't stop you doing daft things if you do something else to sort of cope with that. But yeah, you don't have to meet the backstops. There are. Well, let's be clear here. We've been talking about backstops. Actually, there are backstops, which are there to do with controlling interstitial and surface condensation. But those are very low values. They're something like a 0.7 for a wall, and that's to do with coping with condensation rather than energy. But you don't have to meet the values that are used in the target.
I think an important point is to realise that regulations themselves are actually fairly small in terms of the numbers that are there and the words there. Technical handbooks are just guidance. I'm not going to say that you don't need to meet the backstops, but they're there to be targeted, and they should be met. I'm not sure if the question is looking at the notion of building and the targets that are in there. But again, those I think are slightly different from the backstops. But those notion of buildings, they're not there to be designed to. They're there because they just have to be. There has to be an issue at this stage making calculations.
To add to that, though, you should be trying to target the same U values, if not less, than the national building, because if not, you'll struggle to pass it.
Yeah.
So especially when you then account for the way it calculates HVAC efficiencies, non-domestic specifically. So you should be targeting the notional, if not better. But there's flexibility.
And it's also worth saying that the values that are used in the target, certainly domestically, perhaps also for non-domestic, but certainly for domestic, were set with reference to information in EPCs for new dwellings. So Building Standards Division were able to look at all that information on what is currently being built and saying, right, we can see walls are commonly achieving the 0.19, 0.18, 0.17. So that's a reason for setting those targets. They're not set as something that isn't actually readily achievable. And absolutely, as I said, Bill, fabric first is always the best way to go.
Okay. Question from the room?
Yeah, the question I have is probably hypothetical scenario. So you might not know the answer, but you also talked about the move towards 2024 and moving away from fossil fuels as a heating source, and that we move fully towards electrification of heat. If a development experienced a situation where, for example, the distribution network operator does not have the capacity to satisfy the demands of that building, how would that be viewed and addressed from a building control perspective in terms of dispensations or relaxations be permitted in that scenario? Because I appreciate that probably the network operators, the utility companies, aren't working at the same pace as these regulations may well be evolving. So has that scenario been considered, and how would that potentially be viewed and addressed by building control?
I think it's worth, we'd pick on some of the end of your presentation around 2024 standards themselves. At the moment, the energy standards aren't changing from 2024. So you mentioned that energy standards changing. The only thing that is going to happen is, as you said, is going to cut off the direct emissions heating system. So at the moment, there aren't going to be any fabric changes from April 2024. Okay. But yeah, just on the point around just cutting off the say gas boiler. Yeah, I don't know if there's any dispensations at the moment. I'm more technical side, probably more of our practice unit. But I do know there's a lot of work in the background with energy suppliers. I know, I think Ofgem work with the electrical grid up here, and they do model. But that's more of a national scale, and it is known that local decisions is actually quite a difficult thing for them to make. So the substation next door to their housing development, that's something that they can't model. I suppose all I can say is that the earliest that you put an application into just to spare just the local electricity network is going to help, and they're well funded. They get their money. They're going to take the application on. I don't know if that answers your question at all. But certainly the dispensation, I'll take that away. I'm interested. Yeah.
Happy to just quickly jump in on that, because yes, I had clients where, particularly through here in the West, where the district network operator was looking for a new substation for a relatively modest project. My understanding is that they've now they've looked again at how they calculate that additional demand, and they've factored in the fact that if there's a lot of PV power coming out of the development, some of that is being used on the site, so therefore the overall stress is going to be reduced. I think some of the other things that will come through in terms of the regulations in PV diverters, batteries, etc., will help with that, because it will help balance the supply and demand. The flip side of that is moving towards more EV charging, and that was certainly something that was discussed in the working group as a recognition of, it'd be great to have EV chargers for everything, notwithstanding the fact that not every EV charger is the same, so therefore which one do you try and put in? But then there was also a recognition in the working group of potentially you could create a massive additional load, which would actually be unused until we get more EVs on the road. So it's a constant attempt to balance these things, and one that we could say, well, that's where we're going, let's do that, but the infrastructure might not cope. So but I think everyone's learning through that process and accommodating where we're going.
Okay, any more questions?
It's just to carry on for this scenario. So let's say the infrastructure can't allow you to put back into the grid, so if you don't use it, you lose it. Yeah. So going all electric, depending on the size of the project, these electrical demands are quite high. you know. So with that and an EV introduction, the grid's going to struggle with that as a collective moving forward to the 2024-2030 targets. So what I'm trying to go for is, if we have the scope for TV in the job, would you feel that try to use it for thermal generation to reduce those loads? Would that be the kind of best way forward rather than the electrical side?
I think certainly on the electricity grid aspect, it's slightly moving away from public standards itself, so that's our onshore electricity teams. Certainly in the meetings I've sat in on, there's been no concerns expressed regarding the national scale of electricity generation, gigawattage. It is going to be on project basis. In terms of the local scale, anything the building can do, which is why we're starting to look at delivered energy, PV export, trying to make that more efficient at the building level, so battery storage and, like you said, putting diverters into hot water tanks, anything like that. But it's an experience from practicalness. You mentioned some additional options. Or,
yeah, I mean, they're all just options at the moment. I say on a lot of projects we've got at the moment, there's always an issue with what a new electrical substation or what's going to have to go on a project. I mean, it's now anything over 25 units seems to be a new substation you seem to need, which adds 80, 90 grand onto a project. But yeah, and I think everyone is fully aware that the grid in Scotland is not great. And if everyone in Scotland has an air source heat pump tomorrow and everyone puts an EV charger on their house, then we'll end up just going back to the dark ages because it will all just explode. That's just my opinion. But yeah, so someone has to be done about it, and I think it's great that Scotland's got the greenest network in the world, but we have to try and figure out how we make that network work first and what we want to do.
And one of the things we haven't talked about collectively that much, I touched on it a little bit, but the role that solar thermal potentially has to play. It strikes me that solar thermal has become a little bit overlooked because of the introduction of PV. But actually, if you want to create hot water, it's much more efficient to do that with solar thermal. And it will be interesting to see if more projects come forward that actually starts looking at solar thermal in terms of space heating as opposed to PVs and diverters.